Okay, so this is chapter 3. This is the one about simultaneous equations and inequalities. We'll start with the different ways of solving simultaneous equations, which mainly are GCSE, and so therefore I've put into the basic section. So we had these linear simultaneous equations. There's a few different ways to solve them. So by elimination is the way that you'd probably start out by doing that. That's the stop method, so you make one of the coefficients the same, and then if it's the same sign then you take away, and if it's the opposite sign then you plus. So in this one I have multiplied the bottom by 10, and then I would take those away, so the bottom one take away the top one, so 60 take away negative 17 is 77, and then you'd solve for x, so 1.4, and then you'd solve y by putting the value of x back into one of the equations, whichever one you want, probably the one with the smallest numbers, and solve it that way. Now, most of the time, you're not going to be doing that at A-level, sorry, that's about GCSE skills, even on foundation GCSE. So, the other ways, other methods are, say, substitution. In the substitution, I've made y the subject, so y equals 6 minus 6x, and then substituted that value of y into the other equation. So you get 5x plus 10y equals minus 17. Expand, solve for x, put the value of x back into one of the equations and find y. So a lot of similarities. One of the ways which becomes more and more useful at A-level in order to solve simultaneous equations, or at least find when you have solutions to simultaneous equations, is to do so graphically. So you would plot both of these. So this one's quite easy. It's y equals minus 6x plus 6. So that's this line here. And then this one's a little bit more awkward. It's going to be y equals minus 5 over 10, so minus a half x minus 1.7. So that's this line here. And you can see that they cross there. The x coordinate is going to be 1.4, and the y coordinate, I believe, is minus 2.4. But mainly the reason you would use a graph is to show that there are solutions. So it's not always going to be two linear expressions or two linear functions. We're going to have a linear and a quadratic, which could cross twice. They could cross at one point, so that's a repeated root, or they could not cross at all. So as well as using the discriminant to do things like that, you can also show that graphically. When it comes on to things like trigonometric graphs, then it's going to be even more useful to draw a sketch of the thing, of the two functions, to show that they only cross in one place or two places or an infinite amount of places. The final way is on the calculator, so I'll show this better on the video when we answer the questions, but you want to press the home button, go to equation, and then simultaneous equations. It will look, I don't know if you can even see that, it says two unknowns, that's what you'd choose, and then you'd put in your values of x, y, and the constant. When you do that, you need to have rearranged both of them into the form something x plus something y equals something. So in this case, just make sure you put in these numbers in the right way round so that the solutions come out correct. Also, you might find that in the question it's not x and y, it's a and b, or s and t, probably not s, or p and q. Right? Whatever the variables are, the calculator only does x and y. So you have to choose one of them to be x and one of them to be y. So I'm just normally doing it in alphabetical order. So if you've got p and q, p will be what I put before x, and q will be what I put before y. So those are the four ways, and they become more and more important as the algebra gets more and more difficult. So when we do year 13 mechanics, substitution becomes a massive thing because we end up substituting a lot of equations into other equations. When you start doing vectors, a lot of the time you're solving simultaneous equations. So being able to do that even when there's algebra involved is very important. Also in the basic section, I know it's not underneath basic, but it's solving linear inequalities, which should be simple enough, hopefully. Take away the smaller one if you've got a variable on both sides, take away the smaller one, take away 5. And the only thing I would point out with solving linear inequalities is when you times or divide by a negative number. So for example, if I'd have taken away 3x and then added 4, I would have minus x equals 9. If I wanted to change that to be x instead of minus x, I would have to times by minus 1 or divide by minus 1, that's the same. And doing that, you have to flip the sign. Okay? So if ever you times or divide by a negative, flip the sign. And what I mean by that is, if it's less than or equal to, it becomes greater than or equal to. Here, all I've done is just turned it around. I've just read it backwards. So x is clearly greater than, because that's what the crocodile's eating. Okay, so moving on to intermediate. We're looking at solving quadratic inequalities. So I would recommend, you can always do 3x squared and 10 minus x as two separate graphs, like two separate lines on the same set of axes, but I would always recommend this. Put everything on the same side and make it equal to 0. Well, not equal to 0, but less than 0. Then I'm just going to solve it. So using the polynomial part, I can find, if it were equal to 0, I can find the roots. So that's still going to be a useful thing to know, is when the roots would be. So the roots would be 5 over 3. So I'll put this in, because it's not actually what we're doing. What I'm doing is I'm just finding where it crosses the x-axis. So it's going to cross the x-axis at -2 and positive 5/3. It's a positive leading coefficient. So we're looking at a graph that looks like this. And then, so most of that is just the same as doing anything with a quadratic. When it becomes a quadratic inequality, we're just looking at the x values which give a y value less than 0. So forget anything which is above the graph, above the x-axis. Forget all that, because that is greater than 0. And so what we're left with is just any x values between -2 and 5 over 3. So if this was to say less than or equal to, obviously you put less than or equal to signs here. If it was to say greater than 0, then you would forget what's under the graph and just do what's above the graph. I keep saying graph, I mean the x-axis. What's above the x-axis. So that would be anything where x is less than -2 gives you something which is above the x-axis, and anything which is more than 5 over 3 is going to be above the x-axis. Moving on to the advanced stuff, we're looking at, I missed out regions. Regions I would say was in intermediate. When I say regions, I mean if you've got more than one inequality on a graph, then say for example, I'll just have this one. We know what the x values are, but if I had this was less than something else, like a different equation, actually that would fall into this bit, which you've got one function and another function. And if this was, say, less than, what's the easy way of doing that? Normally you have like multiple equations, and the region is when it satisfies each of those inequalities. So normally it's straight lines, so you'd have like multiple straight lines, and you're looking at which parts of those, of the coordinate axes satisfy the inequalities. So I'll just do a quick example. So if we had y is less than 2x, I would draw the line y equals 2x, and let's make it less than or equal to, because with less than or equal to is a solid line. If y is less than 2x, that means you're looking at everything underneath that graph. If we had multiple, so say x was less than 5, that would be a line that goes through x equals 5, and we're looking at everything to the left of that. And then if I had a third equation, or inequality I should say, which is, say, y is greater than x minus 3, we go to minus 3, draw a thing for y is greater than minus 3. So I'm going to draw the line, if I can get my words out, of y equals x minus 3. Which will go like this. And then if y is greater than x minus 3, I'm looking at stuff which is above that line that I just drew. So if we go through each of them, y is greater than x minus 3, that's this line, and I want the stuff which is above it. Y is less than or equal to 2x, that's this line, and below it, because it's less than. And then x is less than 5 is to the left of that. So the region satisfying all of those inequalities is that bit that's shaded. Okay, those questions are infrequent, but they could come up. The final one is the one where you have two functions and you're looking for the x values which satisfy, for example, f of x is less than g of x, in which case you're looking for where f of x, which is this line here, is below the x, below the g of x line. So for that, you want to find the point of intersection, which I found down here, and then you're just considering x values to the left of that point. So this one would be x is less than minus 2.4. Okay, because this line is g of x, this line is f of x. So if f of x is less than g of x, that means that the line f of x, which was f of x, this one is below g of x, just literally below it on the graph. And that is, I think, everything from chapter 3. Now it's time to have a go at the homework questions. Thanks.